You can also sit in the front row. There's a lot of space. Jedna. Tady je to lepší. Jedna. Halo. Jedna. Halo.
Halo, prase kozu potrkalo. Teď to mluví dobře? Ty neumíš mluvit?
Asi neumím mluvit. Jo, jedna, dva. Čau. Super. Jo, bude to? Mhm. Okay. To musím zkoušet? Nemusíš, bude to fungovat, je to stejný Mac, takže to bude fungovat. Jo, super, tak jo. Okay. Oh, hello. Jedna. Everyone.
Halo, prase kozu potrkalo.
Hello everyone. Hello everyone and thank you for coming.
Je to 2-4 jak?
Halo.
Halo.
Jedna. So, hello everyone and thank you for coming. Today is our anniversary edition, Backendisti number 10. So, guys, can you come in and you can eat the pizza later? or you can eat it here. It's allowed. So, I would like to thank the social bakers for renting us or providing this space, which is really nice from them. Also for the refreshment, which you can find in the back part. And you can also connect to the Wi-Fi. You have the access credentials in here. So it should be available during the whole evening. I think that's it. So I would like to introduce our first speaker, which is Tomáš from Avocode.
Oh. Is it working? Yeah, can you hear? It doesn't work. Okay. Hello. So let me set up the presentation first. Yeah, so here it is. Welcome to the talk. I'm Tomáš. Okay. So I shouldn't go here, I guess. Okay, so hello, I'm Tomáš. I'm the CT Avocode. And can you hear me all right? Even can you hear me? Something? Okay. Thanks. Does it work? Aha. Ne, tam je. Dobrý. Sorry for the technical interruption. Or maybe give me the microphone. Yeah. Sorry.
1, 2, 3. Hello. Okay, so let's start now. So, I'm Tomáš from Avocode, and I want to talk a little bit about our backend architecture and how did we manage to process over 1 million of design files last year. So first, what is Avocode? Does anyone here heard? Did anyone of you heard about Avocode? Raise your hand. Cool. Yeah. So it's a tool that helps designer and developers collaborate when developing web and UX applications. It all started in 2012 when a product from a small Prague-based agency was launched. It was called CZZ, and what it did is a Photoshop plugin that gives you a panel inside Photoshop, so you can just click on the layer and get a CSS snippet for the selected layer. It helped front-end developers code their websites very fast, and we added more plugins in Photoshop that could help with other aspects of development, like Enigma for image export and other tools for iOS development that could make it easier to program iOS apps. So the developers were pretty liked our tools, but the problem was still need to use a combination of tools to actually get the workflow. So the idea was to combine all of these plugins and make it possible for developers to give them a new tool that would actually give them access to the designs. They could open the design and inspect and get all the code assets, colors they need. We started with a beta version in 2014, quickly got quite a lot of subscribers, and supported uploading designs to our cloud application through the plugin. It was just 8 of us at that point, and I was the only really backend developer at that time. In the next years, we did a lot of things. We went through the 500 Startups Incubator in Mountain View, California, which helped us a lot with business decisions and marketing. And we released over 100 new versions of Avocode to finally release the latest major version, Avocode 3, which actually gives you an option to upload all the mainstream formats without the original design software. He also grew by 20 more members, so we are a company of 28 right now, and we have more backend developers, not just me. In time, we also added more features like collaboration. You can comment on design, get notifications about other people talking about design, and we streamlined the file and versions management for the whole companies, so they can use our code as a single place of truth with files and version management in place. Our code also helps designers, because previously they needed to create specification with assets for the developer. They also, in some tools like Sketch, they needed to explicitly mark some layers as exportable for the developers to actually get assets for these layers. And our code helps you with that, because you can, thanks to our rendering engine, you can actually export any layer you want. We also launched our code SDK teasing page, which is showcasing our technology, and and it shows what it can be used apart from the Avocode product. Some stats for the last year: we processed over 2 million of designs, which included around 20 million of artboards or design screens, and it amounted of about 50 terabytes of data in total. So here you can see what Avocode actually looks like. I'm not sure if everyone can see it properly, but basically you can open a design and see how it looks. It's usually perfectly precise. So you can see the design, how it looks in the original software, and you can export code, assets, and see the layers. And you can even hide and show layers that were invisible. So that's for the introduction about what Avocode actually is. Let's see how the design processing actually work inside. So the processing flow actually consists of 3 general steps. We need to get the design from the user, of course, then parse the design file to convert it to Octopus, which is our own design format, and then render the design. So, about each of the steps. First step is parsing the design. That means taking the file like a PSD from Photoshop and actually process all the layers inside and all the information. And what the first step basically does is JSON serialization. It's not even needed to be done for all the formats, because some of the new formats like Adobe XD is already JSON based. Then we convert the design to our own format, which is a pretty interesting technology. It's a common format that describes the features of all the layers inside the design. We can convert all formats like Sketch, Photoshop, XD, Illustrator, and Figma, which is probably all the mainstream design tools you could have. And it's JSON-based. We have JSON schema to validate the data, and and yeah, the last step of the processing is actually render the design, so the user can actually see how does it look. What we did is an engine we call Monroe engine. It's a 2D rendering engine that's written completely in C++ with some OpenGL parts as well, and it's running natively in backend inside Linux. And for the client, we have JavaScript built actually because we have used the tool called mscripten, which gives you an opportunity to actually compile the C++ code into JavaScript. It sounds weird, but it actually works. And the JavaScript code is usually around half speed of the native version. And lately, we've been even compiling the code into WebAssembly, which gives some better performance. Better performance. Yeah, so that was the general steps of how does the processing works for us. And this is illustration from our SDK page. It's not really visible here on our monitors. So the parser, octopus, and Monroe machine. Thanks to our this technological stack, we could do even other tools, like even completely different products from our code. One thing we actually did previous year in 2017 was a converter that takes the octopus format we have and writes a new sketch file, so like a inverse operation. So we use that to give people an option to convert PSD to Sketch, because Sketch is gaining popularity and a lot of designers are migrating from PSDs to Sketch. And this tool we created just uses our existing PSD parser engine and the octopus to Sketch writer to actually create sketch files out of our code designs. So we bundled it into a new product that has over 100,000 of users already, and it's a first Google result actually, and you want to convert from PSD to Sketch. In the future, we would like to definitely revisit this converter and maybe do more of them. So that was a quick overview of how the processing works, and I had some stories when trying to parse the different formats. I have selected 2 highlights that happened in our development. So the first format we actually started supporting was Photoshop. It's very old format. It's from, I think, 1992, and it's still backward compatible. So the format contains a lot of historical data. And the cool thing about the format is that there is a bitmap for every layer inside the design, and also a bitmap of the whole design, which you can just take and create, for example, a PNG, and we could use that to actually cheat a little bit, and we use these bitmaps to show the designs without even before we actually finished our own rendering design, and this helped us with the growth. maybe more interesting part was trying to support Sketch. Sketch is quite a new software. It was made primarily by a few Polish guys, and it was gaining popularity since 2015, I think, and it's only OS X application, so a lot of developers had the issue of not being able to open these designs at all because they had Windows or Linux, and just weren't be able to open Sketch. The file format itself was plist based, binary plist, which is OS X technology to serialize objects. Sketch was very actively developed at that time. So we wanted to start parsing Sketch files, and to do that we needed to actually understand the plist and find some tool that can actually read it, because it was quite hard to do our own implementation. There are a few tools existing, like PL-util, which is OS X only, also some Python and Perl scripts implementation, but in the end we decided to use Go. There was an open source project called Go PL-util, which was pretty easy to use, and it was quite performant. Yeah, so we started like implementing this parser, and we're happy with the development because it was working quite well. But then there was a little like April surprise for us. Yeah, this is version 43 out of the Sketch changelog, because at some point Sketch developers decided to actually use JSON for their format instead of these PL lists themselves. So they released a new version, and one of the first enhancement was revised file format. So that was a surprise, and when I tried to open Sketch file created in the new version 43 in my Linux workstation, I could see that it's just a zip file now, which was pretty cool actually. So, while we did some work on the PL list binaries that was not really needed at the time, this helped us understand the format quite quickly, and we even used the tool actually, because even in this version of Sketch there were still some weird JSON data inside the file. For example, each text layer had this property that looked like this, and it's also the plist binary data encoded in base64. So we could actually use our Go library on production. Another interesting feature of Sketch is reusable components, which is a big thing now. You can actually define components called symbols inside Sketch, and these can be nested and reused into multiple places. Each of the Sketch instance can be then overridden, and you can even overwrite the nested symbols and replace them by others. This was pretty crazy, as you can see on this design. That is my favorite, is the bots library by a guy called Pablo, and it's showcasing how the symbols work. This is like a single symbol instance, and on the right side you can see all the symbol instances nested inside it, and you can actually change, for example, the mouth of the robot or its ears or eyes just by changing the symbol instance override. So I could just change the mouth of the robot by simply changing the override like this. And and this sketch file has a lot of other options, so you could create a lot of dynamic robots. So you had to, that was maybe the most complex part of the sketch parsing, because the JSON format actually only contained references to these symbols and override definition, like replace the mouse of this robot with a different one, and yeah, we made a whole tool for this. And apart from just overriding, there is also some fluid resizing logic that was pretty hard to reproduce, but we were able to do it in the end. Yeah, so that was some things we noticed on our development, and after that I want to show you a little bit about how the backend architecture actually looks like. So I am a big Python fan, so we started the application as a simple Django API and Celery application with PostgreSQL as the database. Just from the beginning, we used cloud storage, S3 in our case, to store all the design files. In the beginning, the only way to upload files into our code was the plugin, which we soon refactored and changed our architecture a little bit. As we started doing different kind of parser and Octopus for all the different design formats, we needed a little bit different architecture, and we started adding more smaller services that made our architecture look more like a microservice architecture. We started doing like these PSD parsers, other parsers like XD and Sketch, and also we had another service called rendering worker, which actually renders the design on the server. And as these these workers started piling up, we had some issues with maintaining all of the code and making sure they are as effective as possible. The queues here are using RabbitMQ as the implementation, and so for that we actually created like our own small library that is a simple RabbitMQ consumer using the PK library in Python. It's built using Python 3, and it has all the tools we need in all these workers. Usually the parsers and other services they obtain some input files from S3, run the actual workload, and then upload output files to S3. So creating like a small library could reduce the repeated logic that had all the services, and we also added some tweaking, like because the actual files that we got from the users could be very different in their complexity. We had to look for tasks that the tasks were actually working quite different every time. So we made some features like good configuration of timeout and retrying of the tasks. And usually we also used some kind of fallback logic that every task had a first deployment that was smaller and with less CPU and memory resources. And this worker could complete 98% of tasks successfully. But if there was a task like someone uploading a PSD that had over 50,000 layers, that would probably time out in the first worker. We had a fallback set up for a heavier worker. Also, all these workers are actually auto-scaled based on the queue size. And we also added support for Google Cloud Storage as we migrated to Google Cloud. Yeah, moment. Thanks. Yeah. So as the worker library actually used the Pika library as a requirement, and we have like a history of naming things uniquely in our code, we decided to call the worker library Pikachu just after the Pokemon, which was which made all our Pokemon enthusiasts happy. So I wanted to look a little bit of on the infrastructure and where these workers and services actually run. We started with Amazon and just using a simple setup of machine images at first. That was when I was the only backend guy in the beginning. This made it possible to like scale the configuration a little bit, create new servers for Django and Celery, which were the only first two components of the whole stack at first. But it was, of course, not very effective as our processing load changes a lot. For example, during the day, there is usually a lot more traffic and a lot more designs uploaded by users than at night. Of course, when this was like in 2016, and all of us added a few more backend team members, and we liked Docker. It made it more easier to make all the tasks run in the consistent environment. We probably are all aware about that, but the main question was about how to orchestrate all the Docker images, how to auto-scale them and configure it. So so there were a couple of options at that year. We are thinking about CoreOS Fleet at first, or something like Docker Swarm, but of course Kubernetes looked promising, but a little bit too beta for us at first. But when we actually looked into all our requirements, it actually seemed like a good solution. But there was some kind of, there is definitely a big like learning curve for everyone to learn how to use Kubernetes, as they essentially created a completely new vocabulary and a lot of new terms we had to learn to actually be able to create a new cluster. At first, we started using tools like Kops to create the whole cluster inside Amazon. It's a tool to create Kubernetes clusters in both Amazon and Google Cloud Platform, and it worked fine at first. There were some issues because it's quite difficult to actually configure and to get into all the network providers Kops gives you as an option. At first, it took so we started our Dockerization of all the components we had. At the time, there was the Django and Celery apps, and we started doing these parsers I mentioned before. So we started them as Dockerized queue-based workers, and also we we had our database that was on the dedicated servers. This was actually a pretty long journey that took over a year before we actually moved all our infrastructure inside Kubernetes. As we added more and more services into Kubernetes. This created a lot of like configuration mess in our infrastructure. So we started looking for some kind of tool that could make this easier. The great tool I could recommend is Helm. It's a tool to manage more complex Kubernetes services. It can reduce like configuration that can be copy-paste into multiple charts, as a lot of the workers had a lot of usual similar configuration. Like for each of the workers, we needed to create a RabbitMQ-based autoscaler, and this helped us a lot by with its features like charts that could be charts and subcharts. So you can create a chart which is essentially a collection of configuration for some tool, and you can define requirements for each chart. So we just made a Q autoscaler chart, subchart, and this is used by all our workers to actually have the autoscaling worked out. We also had some issues with COPS. We used the default network provider, which is called Weave. It's quite like a good tool that you could use and has a lot of features, like you could even have an internal network spanning multiple server providers like Amazon, Azure, and so on. But for our use case, it was maybe a little bit too much, but it was the default network provider for COPS at that time. What we found out after a while, when some of the services were already on production, the default connection limit for the Weave network is 30 peers by default. So in one day, there was a little bit higher traffic than usual, and we needed to start more nodes than normally we needed. And as soon as we created the 31st node, the new node was not actually able to join the Weave cluster, and this caused some slowdowns in design processing at that time. We also hit some other issues like IP range depletion. In Amazon, we tried to run as cost effectively as possible, which means we also used a feature called spot instances, which are like a normal EC2 instances, but for the fifth of the cost. The downside of spot instances is that they can restart at any time, which was okay for us as the worker queue-based architecture could survive these restarts, and for stuff that actually needed to run online for a long time, we didn't use spot instances. Yeah, so after having these issues with Weave that were pretty hard to debug, and we are already looking for some other solutions, and in the end we actually chose the managed Kubernetes solution by Google, which is probably like the best on the market at the moment. At that time, there was no like Amazon and DigitalOcean and other options available. So for our use case, we actually thought about migrating our production stuff and the whole cluster into Google Kubernetes. We started like testing it on some staging providers, on some staging workers, and it looked like a much better solution because the managed cluster, because Google also configures all the cluster and network configuration for you, and we don't need to tinker with things like Weave. So after a few months of testing, we decided to migrate to Google Kubernetes engine. This was actually quite simpler than we thought, as a lot of the Kubernetes configuration could be simply reused on Google. You're able to do the migration in, I think, 3 months in total, including all the testing of the staging worker services first. But maybe the main challenge was doing the DB migration, because as we migrated some services to Google, there was some latency between our Amazon zone and Google Cloud zone. So we actually so we prepared a script that was able to dump the PostgreSQL database, and even for the size that was quite big at the time, we were able to do the migration in with a downtime of just 40 minutes. But maybe one thing that was interesting that we experienced in Google Cloud was preemptible instances. This is something like in Amazon when you have the spot instances with the fifth of the cost that can restart at any time. But in the case of Google Cloud, these preemptible instances always restart at least once per 24 hours. These are the servers that are not used by the normal customers, and Google just provides them for a small cost. But the downside is the restarts that can happen at any time. What we found out is that if you use the preemptible instances in Google Cloud, it's as easy as just creating a new node pool inside Google Cloud Kubernetes engine. Google Cloud usually for preemptible instances gives a signal to the machine 30 seconds before preemption. However, the Kubernetes engine didn't support handling this signal, and this created some kind of mess in our infrastructure, because the Kubernetes took also quite a long time before it actually detected that the node was down, and all the services running on these nodes were still inside the load balancer, and this caused some requests to time out without actually going correctly. But on the other hand, these like preemptible restarts helped test our infrastructure a little bit. It was something like chaos engineering in Netflix, because as it restarted all the services quite often, we could make sure that all of our infrastructure, including all the processing workers, are highly available. And in the end, the Google support actually told us about an unofficial project that is quite new. It's called Kubernetes Node Termination Handler. It's a thing that you can install on your cluster, and it's a daemon set, which again in the Kubernetes vocabulary means a service that will be run on every of the node. It pulls internal Google API and gives you, and that will give it a signal about the termination in advance, and it will just cleanly set up, it will just cleanly terminate all the jobs with a normal term signal, so they can clean up their work and terminate. Yeah, so that was the one tip we found out on Google Cloud, and that will be the end of the presentation. So thank you for your time. Yeah, so there will be some time for questions I showed you a little bit about the infrastructure and what we did. So if you have any questions about that, let. Mm-hmm. You mean in Avocode or no? We still use Go on in many services. Actually, like for example, that one component that is turning Octopus, our own format, into sketch files that's written in Go, and we also have a few more services like that. But like the main Django and Celery app is still in Python, but we will probably change that in the future as well. Yeah. Any other questions?
Okay, if there are no more questions, you can still catch up, Thomas, after the talks. I'm sorry about the technical problems in the beginning. The microphones are running on 2.4 gigahertz and it was working fine. But when you came in and started using your phones, it probably started making some problems. So sorry about that. And we'll have a short break, about 10 minutes. So we'll start with the next presentation at 7 p.m. we can continue with our next talk. So I would like to introduce Jan from Epify, who will be talking about how you can easily host your open source project in the cloud.
Thank you, Victor. Can you hear me? Okay, I hope everybody can hear me well. So, hi, my name is Jan Churn. I'm from a startup called Epify, based in Prague. And today I would like to tell you about how you can easily host your open source projects and give them live presence in the cloud. So before I start, I'll give you short introduction about Epify. It won't be that long. So as you probably know, the web is probably the largest database of information ever assembled by the mankind. On the web you can actually find pretty much everything, right? But the problem is, most of that information is not easily accessible for computers or in a structured form the way you can use it for automated processes or at scale. So web was primarily designed for people. So you have nice websites, but not every website in the world has an API. And even though if websites have an API, quite often not all the information is available there, So at Epify, we created a tool and a platform which helps you to basically turn any website into an API. It's a cloud computing platform where you can set up jobs to extract data and to publish them the way you want or integrate them with our services. And basically, in our opinion, access to data is actually one of the elementary freedoms people should have, and we should be able to access data in a way we actually want, not the way the data providers are forcing us to, Because once you have access to data, you are free and you don't have to depend on basically how the large corporations provide you with access to the data. Especially that most of the data is actually collected by us people. So we built a platform which helps you to turn any website into an API. That's why we are called Epify. So, as you can imagine, extracting data from websites, also called web scraping or web crawling, typically is kind of custom job, Every website is different, and if you want to create some data extractor, you need to typically write some handmade code, There are tools that can make it for you using some user interface. But if you want really the possibility to extract the data the way you want it and the information you want and to make it work on every website, you actually have to use a code. So as you can imagine, we need to be able, as the Epify platform, to run user code and allow people to run pretty much any code on our cloud system, right? So I guess anybody who tried to provide their users with the ability to run the code in the cloud found out that it's kind of complicated, It's difficult to run your cloud solution if you have predefined jobs, and now you add total uncertainty about what can you run there, So a few years ago, we started our first approach was a simple tool that could extract data. We were using some old Phantom.js headless web browser, so you could only write a short code in JavaScript that would run on every web page we visited, and then you could extract data from that. But this approach had many limitations, because people wanted to access different kinds of websites that, for example, didn't work with Phantom.js, or they wanted to upload the data to S3, or do some custom integrations. So we built a new platform that can run these kind of jobs. And basically, whenever you have to run user code, in the cloud, and the people don't have to worry about the servers, and they can run it at any scale. So it's basically serverless, right? So what we actually really needed to run these kind of jobs where people can write any code was some sort of serverless platform. But unfortunately, the traditional serverless platforms, like you would know, like AWS Lambda or Google Cloud Functions or this Apache OpenWhisk, they only support like very short transactional operations, you know. So typically there is a limit of 5 minutes of what you can do on the serverless platforms, like they are called like function as a service. But when you want to crawl large website, for example Amazon, and want to download like 1 million pages from that, you can't do that in 5 minutes. So we needed some different platform where we can run some different serverless platform where we can run jobs that actually take longer than 5 minutes. They can actually run for hours or days. But at the time when we started, there was no platform available to do these kind of operations. So we designed something. Yeah, I should have put this slide before. But anyway, we designed a platform, serverless computing platform called Apify Actors, where you can actually run jobs that we call Actor. It's like a cloud app. You can basically develop, build, run, and publish on our platform. And the actors, they are kind of different to traditional serverless platforms. So you can start it using an API, that's kind of normal. You can start it also manually in the app, in a user interface, which kind of helps you when you're debugging the new actors that you have just built. Or you can run it using a scheduler, for example, if you want to run your job every day. And under the hood, actors are actually using Docker. So like when you define your actor, you provide some source code that can be hosted on, for example, GitHub, or you can have the code hosted directly on our servers on Apify. So you can actually use an editor and develop the code directly on our website. I'll show you later. Or you can push the code directly from your development environment using some command line tools. So we try to create an open serverless platform where you can easily develop, build, run your jobs, and also publish them for other users to use. And then in the actor, you can run pretty much any Docker image that you want, and so it can do pretty much anything. But we created an SDK, which is especially designed for data extraction jobs. And so it has some tools which can help you to use, for example, headless Chrome with Puppeteer to extract data from websites. So we created this web scraping library for Node.js and JavaScript. And I think in September we published it on GitHub, and we got 1,000 stars in about 2 weeks. So there was also great feedback from the community. And today I'll show you how it works live, and hopefully everything will work correctly. So I hope you can see it. So as I told you, we have some command line tool where you can use to start to create your new actor from scratch. The tool is called Apify, for sure, of course. Okay, so I'll create a new actor called Actor Hacker News, and here I can select a template which will be used for the actor. So I'll just select a simple Puppeteer crawler. It just runs automatically for me npm install. I'm using the SDK, which is designed for JavaScript. So hopefully in a few seconds I'll have a running project, which I will open here. Actually, the basic example there is not great, so I decided to just use another example. And this actor does actually a pretty simple thing. I don't know if you can really see it, so I'll just like go quickly through this. So it just opens Hacker News, which is like popular news for developers. It creates a queue where you can actually like add pages that the crawler should visit. And then I launch something we call Puppeteer Crawler, which is just a web crawler that can use headless Chrome with Puppeteer, which is a Node.js library for managing headless Chrome. It's actually created by Google. And I just like write a short piece of code that I run on every page to extract the data from the website, right? So everything should be ready now, okay? So I just do Apify run. Oh. So I just run the actor, and if everything works correctly, you should actually see web browsers popping up, but for some reason, actually they are not shown. Yeah, actually I knew I shouldn't do live demo. It worked yesterday. Oh, here we go. So now, basically, you can see our library is basically automating a web browser. It loads like 5 pages from Hacker News, extracts the data, and stores them into some storages we also provide both in the SDK and also on the platform, which I will show you later. So it loads 5 pages, the crawler finishes, and maybe it will finish. Okay, this is page number 6. I don't know if you can see it. So anyway, the crawler finishes, downloads the data, and by default the data is stored in structured form here in some directory. So this thing you can run locally, but that's actually not very interesting. You could probably create this web scraper yourself in a few minutes if you want that. So what I want to show you now is like how I'm gonna publish this actor on Apify Cloud. So I go to Apify. Go to the actors, create new actor. I hope you can actually see it. Maybe I'll call it, for example, Hacker News. Give it some description. Here I have some functionality, like for example, like the actor can restart on error, or it can use spare CPU capacity. This is not very interesting. And then I go to the source code tab, and here I have various options. So I can either write the code directly here in the online editor, or I can, for example, link it from a GitHub repository and host the code there. So you can develop on GitHub and then just like pull the sources from there. You can also host it as a GitHub gist or as a zip file. So like it's kind of flexible. In this example, I just want to show you. I wanted to show you the editor. So I just paste the code there. I re-enable the live view, which I disabled before. And then when everything is okay, I click save, and then I build the actor. So now what happens is the Docker image is actually built on our servers from the source code you provided. And then once it's built, it's stored on our servers, and then like you can use it by just calling an API, or you can schedule the job to run every day or in a minute. And then it stores the results also to storages in our cloud. So I'll show you an example. I click run. Oh yeah, okay, I chose an invalid base image which doesn't contain the Puppeteer, so there will be one more rebuild. Save, build now. So most of the time you would write source code in Node.js or JavaScript, but the platform can support arbitrary Docker image. So like we have customers who are actually using their own like Docker images. You can run Python code there or pretty much anything. So build finished. I'll click run. And now basically we're running headless browsers on our servers that are extracting data from Hacker News. And like we have this feature which we call live view, which enables you to basically watch the progress. Nothing is showing here. That's also a bit awkward because it worked yesterday. Okay, anyway, here is the console at least. So basically, the crawler opens Hacker News, visits like 5 pages, and extracts information about each article, and then stores the data on our servers, and you can actually see the data in various formats. So for example, here is in HTML, so HTML table, so you can see the links to the stories, titles, and so on. But again, you can also download the data in JSON format or Excel or basically like any format you want. And now, what I'm going to do is I'm going to publish this actor, which is now an actor that basically upifies the Hacker News, and I'm going to publish it so that anybody in the world can just use it without having to install anything locally. So I click publish here, I select some category, so this is an example, for example, and I click save. Yeah. And now what happened, the actor that I just created called Jan Kern /Hacker News is available at address apify.com/Jan Kern/Hacker News. And now even you can try it on your mobile or your computer, and you can actually just use the actor and extract data immediately without having to install anything locally or deploy any infrastructure yourself. So we have this library where our users published like already dozens or hundreds of actors that you can immediately use, and we have actors that work with extract data from Booking.com, from Google, from Airbnb, maybe not. And so for example, if you have some project, some open source project that you would like people to be able to use immediately, so the normal way would be, okay, you upload it to GitHub, or you have the repo on GitHub, anybody can contribute, anybody can use it, but like sometimes it just takes too much effort to set up the project and run it, So like you would provide the users with like a list of steps they need to perform if they want to run the project. But sometimes it's just too painful, So Apify actually gives you a way to publish your open source project directly on our cloud platform so that anybody can immediately use it and work with it immediately. And actually, when they use it, it runs under their account, so you are not paying anything for the cloud hosting. So this way you can, free of charge, publish your work for the world to see and use. So I'll show you another example, more interesting. Just recently, one of our customers wanted to create an actor to basically crawl like millions of domains and extract basic information about each domain. So we created this actor called like analyze domains. So maybe I'll go. So like you can also use it yourself. You just like find it in the library. So you just find it. Here you can see some README for the actor. There's information like how to run it using API or manually. There is definition of input, basically. Every actor, which is like this like cloud in the app, this like app in the cloud, has like some input which tells it like what to do, So it's like a Docker image with input. And what we did is like lot of these actors, they have like well-defined schema where like they expect some sort of data to be on the input. So you can create an input JSON file that contains the schema, and actually we use that file to generate automatically the user interface for manual usage of the actor, you know. So for example, this actor, to analyze the domains, it uses this file, and basically, thanks to this file, we are able to generate a user interface like that, where you can enter, for example, a list of domains and some other, well, some other various parameters for the actor. So like here I have a list of domains like Backendisti, Avocode, Apify, and Social Bakers, and I'll just try to run the actor. And now the actor just visits these like 3 domains and extract all kind of information from them. So for example, it makes screenshots of the web pages, it downloads text, HTML, and like phone numbers, and like social handles, and so on. So now it's finished. I can view the results in JSON. So you see, for example, here is Avocode, which is running on Cloudflare, I see. So here's the list of links, and for example, here I have like Twitter handles for Avocode and so on. So basically, this way, you can easily publish your work if it like makes sense. Like if it's like, for example, like some well-defined job, you can easily publish it and then like just use a link to do this actor and send it to anyone, and people can just use it immediately without any installation and any effort, you know. So actually, from our perspective, this is like kind of like very novel idea, because like until now you would always have to kind of deploy the things yourself, but here you can publish the project and anybody can use it. So finish the live demo. We have this auto-generated user interface which helps people to run the actors manually, but also you can start it, of course, using an API. You can attach webhooks. So for example, when the actor finishes, it automatically calls a webhooks that you want, so we can easily integrate the actors into your workflows. So we think of it, it's like a glue for different internet services, you know. So for example, you can connect it to your workflow in Zapier or IFTTT, and if you need just some custom data from the web, or you need to write a piece of code that does something where there is no tool for it, you can easily use Apify and integrate it to other workflows, you know. Because the jobs are running for quite a long time sometimes, what can happen, of course, sometimes is that the server, where it's running, gets restarted. So like we have like special tools that like manage the state of the actors, and they send you notification when the server is restarting, so that you can actually save the state and migrate immediately, you know. So this way, one job can easily migrate about 20 servers over its lifetime. And it's something we count with from the beginning, and it's especially useful for longer jobs. You can also use it for shorter jobs that don't usually need this. So like we have actors to send emails, you know, to upload data to Google Spreadsheet, you know, there's like a whole like toolkit of actors you can use for your use cases. Sorry. So you can easily publish the actor in the library and share it with everyone. And for example, if you didn't know what kind of actor you could use or what kind of actor you could build, so just a couple of months ago we started like a cooperation with Michal Blaha, who has this project called Hlídač státu, or in English like Monitor of the Government. And Michal basically collects data from all kinds of public APIs from the government, and like downloads information about like government contracts, tenders, and so on, so that like if he can bring more visibility into how the state operates, it will make it work better, you know, and there will be like less fraud and so on. So we partnered with Michal, and we are actually like scraping some data from some websites or from the government that are actually not providing an API. So if you were interested, for example, in helping, there is like plenty of different governmental offices and institutions that don't provide an API, and we would actually welcome people who would just like create an actor for them and download the data. So we're currently working on different examples and like how-tos, how to basically people can get started easily. So if you wanted to do something good for the state, you know, you can come talk to us after the presentation, and we can show you how we can help. Or if you are interested in publishing some other work on Apify Actors platform, come to us and we'll have a beer and talk about it. So that's all, and thank you for your attention.
Thank you, Jan. Do we have some questions? Okay, you can go on.
Yeah, so I'll repeat the
Can you-
question. Do you have support for secrets? And the answer is yes. We have environment variables where you can write, I hope it's the right actor. Yeah, okay. Where you can write any value and you can make it secret. So once you store it, nobody can retrieve it, you know. So even if you publish your actor with a secret value, actually, you can do it this way, and some users are using it, you know. For example, they have like passwords and credentials. So yes. There was one more, maybe?
So you are letting your customers run arbitrary code, and you said you're letting them run any Docker image they want.
Yeah.
Have you run into any problems with security or use?
Well, I'll repeat the question. So the question was whether we ran into issues with security because of Docker or like running arbitrary user code. Not yet, but for example, we already had users who were mining Bitcoins. Actually, it was kind of funny because they were mining, they launched a browser or a headless browser and in the Docker, and they opened some website which had the Bitcoin miner, you know. So it was like extremely inefficient. We were thinking like, why don't they just use some NPM package to mine the Bitcoin? It would be like twice as fast at least, you know. But otherwise, like no security issues. We are using some isolation services and like hardened security. So far so good. Sorry, I didn't understand the question. So, no, I'm joking. So it's about the legal issues. Yeah. So what we actually say is like we provide a platform where anybody can run their code, and like what people do it is their responsibility. You know. So it's like Amazon. Amazon provides servers, and you can run any code there. But like Amazon is not responsible what you run on the servers, you know. So it's always your responsibility to use it in a fair way and so on. But like so far we didn't have any legal issues. And for example, recently there were like quite favorable court rulings in the US which actually legalized scraping more than it was before, you know. So like it's on a good way, and we hope like we actually believe that like anybody should have right to access the data the way they want it, and not the way the companies are designing them to do it, you know. Oh yeah, we are blocked all the time. So we have a tool called Apify Proxy that actually we have like pool of pool of proxies that which you can actually use to like change your IP address and like download data from like different origins, and also you can use it to emulate access from different countries. So if you want to see the website as if you were, I don't know, in Spain, you can do it. No, we don't actually run this ourselves, but there are many companies, mainly from Israel, that are actually providing these kind of services, and they have like, they call it residential IP addresses or residential proxies. And typically it works the way, so for example, one is like company called Luminati, and they are and they are like a subsidiary of a company called Hola, and they provide like VPN. So like you install a VPN on your computer, and you have like private access to websites. But like in the terms of service, you agree that they will also use your computer as an endpoint. You know, so this way they have like millions of IP addresses around the world, actually in every country. Then there are some other providers who are, for example, they have like this like library, and you download some free app. I don't know, it can be like any, for example, game. And in the terms of service, they have like, yeah, we use your computer as an endpoint. So like, there are like legal botnets basically where users actually agree with that. And yes, these are being used to download data from websites, but actually they are kind of slow and expensive. You know, you pay like maybe like $12 per gigabyte on the basic like plan. So like it's kind of expensive. So sometimes it makes more sense to use data center proxies where you just like rent IP addresses from different providers again in data centers, and then you just like intelligently need to rotate the IP addresses and change user agent. But like the companies are using various techniques to block, so it's always like this like cat and mouse game where you need to just always find a better solution. But there usually is some way. Yes, you can use Amplify proxy. All right. So thank you very much, guys, again.
That's a very nice use case. Okay, thank you for the presentation. We'll have a really short 5-minute break, and then we'll continue. You with the next presentation.
Ten podtitulek je dobrý, no. Jo, to jsem nepřišel, to slovo. Alternativ nedáme. Ne? Šubrul. No, a space navíc? K tomuto podtitulu?
Ještě jednou?
Za to tu jde ještě space? To je zpožděné ještě, ne?
Jo.
Se streamuje přes Zoom totiž.
Přes Zoom?
No, tak to je tady váš setup oficiální prý.
Takže to jako přes stát a zpátky, když
Jo, jo.
tak něco.
Přesně tak.
Jo,
Ještě horší. To nejde prostě.
Já jsem šoupnul, no.
Jo. No, to bylo z jinde teda, počkej.
Musím trefit toho rámečko.
Jo, good enough.
So I would like to introduce Martin from Social Bakers, who will be talking about Mesos.
Hello guys, do you hear me? No, you don't? So that's too bad. Hello, hello, can you hear me? No, still bad. Hello, hello, is it better? Is it better now? No.
Hello. So hello everyone. Can you hear me? Yeah, I guess you hear me now. So hello, welcome. I'm Martin here from Social Bakers, and today I will tell you something about Mesos, which is a software that we use here in Social Bakers. It works as an alternative to Kubernetes. So let's get into it. Here in Social Bakers, we focus on helping social media marketers and large brands to optimize their presence on social media. So basically we track Facebook, Twitter, YouTube, and other social media networks. And we create charts, tables from those loads of data. And we are trying to help to measure, optimize, and improve their presence on the social media. To achieve this mission, we created an internal backend API platform, which consists of hundreds of different API units. All of those APIs are running in multiple instances, and in total it makes over 1,000 separate processes. And today I will show you how we manage to run all those processes. Majority of those microservices are written in Node.js. Some of them, like around 10%, is written in Java, and the remaining rest 10% makes a mixture of different languages like Ruby. Actually, we've got one API in R script, pretty interesting, and so on. You know, as a speaker, I'm usually bored when I'm in presentations or conferences, and the speaker basically reads the first paragraph of Wikipedia of that project. So I don't like wasting that much time, but I feel a bit responsibility to tell you a little bit how the software actually works. So I'm talking about Mesos, which is an alternative to Kubernetes, which I guess you all know. It was mentioned in the presentations before. And what it basically does is it takes your servers, it can be either virtual machines or physical servers, and it groups them into a logical cluster. So instead of dealing with those separate servers, you can just have a shared pool of resources, and that's how you behave to it. You don't need to specifically say, hey, I want this API to run on that specific server and another API on another server. You just say, hey, I want this API to run with 2 gigabytes of RAM, 4 CPU cores, and that's it. And Mesos runs it somewhere. Now comes the biggest difference between Mesos and Kubernetes. Mesos itself is like just the kernel of the shared servers. It cannot run anything itself. It just knows how to run some process. It knows the slaves that are in the cluster, and it manages the resources. But if you actually want to run something on Mesos, you need something called a scheduler, or in Mesos terminology, it's called framework. A bit silly name, but it is how it is. So you need a scheduler, which accepts the resource offers from the Mesos, and it actually knows what to run, because Mesos knows only about processes that are run in the cluster, but scheduler, he knows it's an application which consists of 8 instances of the same application, and when one of the instances crashes, he knows that it needs to be restarted, and the cluster needs to, the number of instances must be fulfilled to some constraint. So that's the biggest difference between Mesos, I guess, and Kubernetes. Kubernetes is just like, it can do everything alone. So this is the overall picture of the architecture. You've got, this is like Mesos master. There's a scheduler that talks directly to master and tells him what to run with what constraints, what CPU cores, what memory does it need. And then you've got the sometimes I use the word slaves, but they did change because, you know, it's kind of popular nowadays that people get offended by some words. So the agents were used to called slaves, and I'm still used to the terminology, so sometimes I still use the word slaves. But correctly speaking, it's just agents. Stupid. So enough of boring speaking. Now let's talk about how we specifically use it here. So as I spoke about the schedulers, we use 2 of them. One of them is called Marathon, which is, as the name implies, for long-running units. It's basically web servers, APIs, usually applications that do not terminate itself, and when they do, usually they need to be restarted. There's another scheduler we use, it's called Singularity, which is good for crons and one-off jobs. For example, when we build a new version of our API, it's being built by the Singularity one-off job. So we build a job on Singularity on Mesos, and then we also run it on Mesos. So it's self-sufficient technology. Now, specifically speaking, we are hosting in AWS. Actually, we have mainly two regions we use. One in the United States, where we have the production. Most of the servers are there, and we also have some servers and a smaller Mesos cluster in Frankfurt for development purposes. It's like this because Frankfurt is close to us, so when the developers communicate with the databases and the applications, it's pretty close. You know, one network hop to the States takes like 200 milliseconds, so it's slow. For the master nodes, we use this kind of instance. It's actually the smallest one with 8 GB RAMs and some CPU cores, because the masters itself, they don't do much work. They just delegate and oversee the whole cluster. And then we've got those Mesos slaves, you see, agents. And most of them, like 33 of 36 of the slaves, are the first type of instance, the M5X large, kind of small instances, but we have a lot of them, so we share the resources in this way. And we've got some of them. Actually, it's pretty big instance if you look at it. 128 gig RAM. It's pretty large instances, pretty expensive. And if you remember the portions of languages we use, the Java didn't take that much, but actually those servers are for the Java. Okay, now to the real problems that we had to solve. When you are trying to create a cluster like this, it's independent of Mesos or Kubernetes or whatever. You always have to deal with resource utilization. Everything you run on such clusters, you always need to set up some limits, and when the application tries to exceed the limits, it gets killed. So here I got a real picture from production of one process, And you can see it most of the time it takes around half gigabyte of RAM, but there are some peaks. It might be a large client wants some report, or a client takes a long time range of data and it needs to be processed. So the process sometimes takes way more memory than it needs in the average time. But you have to set up those constraints before you run the actual code. So if you set the threshold too low, the large clients wouldn't get their reports because the process would be killed every time the process tries to allocate the memory. So you need to take the largest peaks, put some gap, so you have some extra space, and then limit the process that way. Which leads to a kind of problem, and the problem is money. If you allocate plenty of memory for each process, it means that you're literally wasting the resources. If you look at this chart, like 95% of the time, you're wasting 3/4 of your RAM. And on the 16 gigabyte server, you can run 8 processes. If I told you we've got over 1,000 of those processes, just you do the math. So Mesos has a pretty nice solution to this, and it's called oversubscription. And essentially, you're faking, or the slave is pretending the amount of resources that he provides. And you can set up a coefficient or a multiplier. So you say the slave is reporting a little bit more memory than it actually has, and you can run more tasks on it, which is fine, and it saves you money. Actually, it's the same like in banking. Like, if every one of you went to the bank and wanted to withdraw the money, the banks would go down. So that's the same like here. Actually, that's the problem that you introduce when you use this approach. You just hope that all the peaks won't occur at the same time, because the server actually doesn't have the resources you're promising that he has. You know, as we don't use what's called a swap, we are not swapping to disk. So once the server gets or starts running out of resources, there comes the kernel and starts killing whatever he finds just to make some free space. So you're just hoping with this approach that the peaks don't occur at the same time. But we are okay with it, and we used to have the coefficient about 1.5. I think now we are lowering it a little bit to 1.2 or something like that. That's the key problem here, to find the best coefficient between, like, you don't get the peaks to appear too often, and you don't waste too much money. Now, another interesting issue is how you actually distribute the code, your applications, to those slaves. Slaves, agents. Actually, when you have an API, you've got some source code. In case of Node.js, it's not compiled, so we have the source code. You need some Node.js runtime. You need the dependencies. What about OS level dependencies? Like, when you have a service that does image resizing, you probably need image magic or something like that. So how do you solve that? Well, we've heard it actually today, and I guess you all know the answer to that: Docker. So we definitely use Docker in our company to build all these microservices. We encapsulate everything together into a Docker image, and then it's okay. So how to do it? Well, you could, like, a classical Docker way approach is to have a Docker file. You do from node 8.10. You add the source codes, do some npm install. If you're a clever and reasonable developer, you also run the tests. But actually, no, that's not how we do it. I guess you all heard about Heroku, which is pretty interesting company, and they do a lot of great stuff. And we got deeply inspired by something which they use in building their applications. It's called build packs. Heroku build packs, they are real simple single-purpose bash scripts that essentially takes your code and transforms them into a runnable piece of software. They literally sniff your code base, and they look like, hey, there's a package.json inside. So it might be a Node.js application. It looks inside the Node.js application, into the package.json, and yeah, there's engines, Node.js, 8.10. So it downloads the runtime, does the npm install, does the tests, and everything is installed when you need it. For example, and we have APIs like those that combine Java and Node.js together. If you did this approach, how would you put Java into this base image? You've got actually two possibilities. Either you do from node and then do run apt-get install Java. Oh wait, you need Oracle repository. apt-get in apt-add repository Java Oracle. Oh wait, you need the key signatures for the repository. Fuck that shit. I don't have time for that. So that's not a good way to do. Or you can create like multiple base images like Node 8 and Java 7, and then you need Node 7 and Java 6, and you can create like a gazillion of combinations. So it's definitely not way how to do it. So Heroku build packs are really lifesavers for that. The great thing is you can run multiple build packs in a series, and each of them does its own job. Install Node.js, run the npm install. If there's a Java, it can do Maven package, however is Java compiled, and do it. One important thing, to this resulting Docker image, we also put all the connection strings, all the environment variables that the application will need. We wrap everything to the Docker. So if you take the Docker image in whenever time, you can download it to your computer and run it. It actually runs the same way as it would run on the server. So everything is tied in the Docker container. Once we have the Docker image, somewhere actually we use ECR, which is AWS private Docker registry. So we instruct Mesos to run this image with this command. We need so many instances, that amount of RAM, and we're good. Another interesting thing that we use is dynamic DNS. Actually, it's when a developer creates an application, deploys it, he always gets a private DNS record for that application, so he can run it, test it, and show it to his colleagues, show it to his boss or whatever, and how it's done. Marathon is one of the frameworks I mentioned already many times. He has an REST API, and one of those endpoints is an event stream, which is essentially a stream of events that are happening with all the applications. Like, hey, this app has crashed, one of its instances, I'm restarting it. The new instance is running, health checks are passing, everything is cool. A new deployment has begun, so I've deployed 2 extra instances of the new version, and now I'm killing the old 2 ones, and so on and so on. So it notifies everything that happens in the Mesos world through this event stream. And there comes another piece of code, which is called Marathon Load Balancer, MLB, and it's connected to this stream, and it actually creates just a simple HA proxy config of those events, like when he says, hey, new instance has been running on server X. I will get to it. So Marathon Load Balancer just creates HA proxy config, and that's it. Single purpose script. It reads the stream and creates a config that HA proxy runs. So then it looks like you've got a couple of Mesos agents, you've got some apps running there, they can, inside the Docker, they can listen on whatever port they want. Some of the ports get proxied outside through the classical Docker bridge interface, so they are available on the agent. And then you've got the Marathon Load Balancer, which listens on the event stream, and Marathon is telling him, hey, I've got those applications running on those ports, so create the routing table, and application X actually runs in 2 instances, the others are running only in 1. And when one of the applications crashes, actually it gets propagated through the event stream, the MLB gets notified about that and removes that task from the routing table, and once a new replacement task appears for that one, it gets notified again and reconnects to the cluster, and it's load balanced back again. The HA proxy config that's generated is pretty simple. You just have a front-end v host, it's not there, whatever. There's just, if the host equals to application X, use backend app X. And there's the app X, which has 2 servers, and when the MLB gets info that one of the server instances is down, it just removes it, and when the new one occurs, it re-adds it there. So you get constant reloads of the HA proxy, and everyone has this DNS name that's load balances to the actual instances. And that's it. Now, I would like to share with you one pretty big fuck up that happened to not us, but especially to me when we were evaluating something. So when the ship goes down. The other day, I was evaluating a new framework, and I needed a lot of resources, so I was doing it on production. Well, you know, that's the first thing you sometimes shouldn't do, but everything is isolated. You've got Docker, you've got the frameworks, you've got isolation on so many levels, nothing can go wrong. So, and I needed the resources of the production cluster. So I started the new framework, I did some research with that, it took me a couple of days. I started some tasks, we're grayscaling them, testing how they behave when you restart them, and so on and so on. I did some private testing. And after a couple of days, I was like, yeah, okay, we don't need this framework at all. It's rubbish. So I went to the server, stopped the framework, and I was done. Unfortunately, it still appears in the Mesos UI, and Mesos still knew about the framework, because everything is done in a way that it's highly available, it's redundant of failures. So he was still waiting for the framework to reconnect, because the typical use case is you put the framework down, upgrade it, restart the server, something, bring the framework up again, and everything goes on. The typical use case, the use case of putting down a framework and never coming it back, it's not that often, so they didn't think about that. So the framework was still there as an inactive, and Mesos was spamming the logs with, hey, this framework is down, but it's okay, I'm waiting for it to reconnect. And actually the timeout for this reconnection is like 2 weeks. So we would have 2 weeks of spam in the logs in there. But the Mesos guys thought about it. So they created an API endpoint called teardown. Actually, it sounds pretty aggressive, teardown. So I was like, yeah, but that's exactly what I need. So in the Mesos UI, I found the ID of the framework, and I was like, curl, Mesos master, teardown, framework ID, and I hit enter. And you know, we have pretty great Slack integration. So everything that happens bad in the cluster, we get notified to Slack, and we've got different teams that are responsible for different projects. So like the right responsible persons get notified that their application is wrong. And as soon as I hit enter, those Slack channels that are like the duty channels, they went on a rampage. It was like constant stream. You couldn't read it because it was scrolling. You know, the Slack bot that was writing all the messages, it kept like, hey, this API is gone, this API is gone, this application is failing health checks, do something with that. Everything literally was gone. You know, from the documentation, tearing down a framework means also shutting immediately all the tasks belonging to the framework. It took me like half a minute to realize I put the wrong framework ID. So instead of tearing down the evaluated framework, I tore down Marathon. But it's okay. Well, everything was dead at the time, like all the APIs, the website, the content APIs, everything, each and every of those 1,000 instances was dead like this. So I started panicking a lot, and then I was like, okay, let's just put the framework back online, because he has its own database, actually in Zookeeper, but that's irrelevant. So I SSH to the server, put the service Marathon start. He started again, he looked at his database and said, oh man, I've got 1,000 tasks that should be running and there is none of them. Hey Mesos, spin that, do it, start everything immediately. So Mesos did what he was told. He started spinning all the tasks back again. And actually, because starting every task means to pull the Docker image, pull some more information from S3. We've got some infrastructure around that, and do some more things, and then run the process in the container. And actually, the slaves got, the agents got overwhelmed, and they started disconnecting from the cluster because it was so much workload for them that they couldn't stand that load, and the pings that they do between the master and the agent started failing, so the slaves started disconnecting from the cluster, and we were actually unable to restart the cluster because the cluster was killing itself. So we tried it like 5 or 6 times, and then we realized it's impossible. So we did like a lobotomy of Marathon. We completely erased his database, the zookeeper. We started him completely from fresh, and Marathon was like, oh yeah, it's okay. There's nothing should be running, and nothing is really running, so we are fine. And then we quickly had to write a script that slowly, or in a batches, I don't know, I remember like 10 or 20 applications at once. He redeployed the apps in those batches, so the cluster itself wouldn't get flooded with so many events and so many tasks. So yep, that was one great fuck up that happened to me like 2 years ago or something. So thank you very much for your And now if you got any questions. Okay, I repeat the question. The question was, why did we go for Mesos and not for Kubernetes? Man, I will buy you a beer tonight. I'm really happy that you asked, and I won't be lying. I expected this question, so I created a slide for that question. You know, to be honest, I definitely don't know that guy. This is not this is not pre-talked before. I really did expect this question, so I created a slide. Why Mesos and not Kubernetes? Well, to understand it, we have to return to like a prehistory era. We started evaluating this way of orchestrating applications back in, what, is not there? My magic trick didn't work. Okay, so we started doing these evaluations in April. Okay, my computer's gone. So we started this evaluation in April 2014. Mesos was like in version 0.0022. Kubernetes was like 0.015. And there was absolutely no documentation about any of the software. There was no support, no paid support, no forums. No one was actually using it, so there was no production ready tips. So we were just like really swimming in unknown seas, and we were able to start using Mesos like 2 days faster than Kubernetes. So that's the way we went for Mesos. Any more? Yep. So the question was how Mesos handles GPU and when you have requirements for GPU resources. Yep, Mesos actually absolutely handles that. As I showed, I always mentioned CPU and RAM, but another type of resource can be GPU. We don't use it at all because it's not our use case, but it works completely the same. The slave, the agent itself, he responds or he shows what kind of resources he has to offer. He reports that to the master, and the master knows, hey, this agent has 100 GPU cores, 4 CPU cores, and 6 gigabytes of RAM. And when you create an application through that framework, for example, Marathon, you say, hey, for this application, I need 2 CPU cores, 20 GPU cores, and some RAM. And he finds an agent that has those available resources and runs the tasks there. And then the task has access to those GPU cores. And if there are servers in your cluster where they don't have any GPUs, such task would never get scheduled there. So thank you very much. Ah, yeah, there's one more. The question is, how do I make the app definition, let's say it like that? Yeah, how do I create the apps? So, sorry, I maybe wanted to mention it, but I forgot to say that. Everything has REST API, and it accepts only JSON. Well, for someone, it's pain in the ass. For us, it's great advantage. So you communicate with Mesos and Marathon via JSON REST calls. So you just do a curl or request to Marathon API and say, hey, I want this application with those constraints. I mean, like, you can scatter it across availability zones. You can say how many GPU, CPU, RAM wants, and he runs it according to the constraints. So the language you speak with Marathon is JSON. One more. Actually, we are starting to evaluate Kubernetes right now, or well, we started before Christmas, but right now we are in the process of installing Kubernetes. The DevOps guys who mainly has it in their competence right now, they are having some struggles with the networking model, because we want to use the AWS. It's not Fargate. They have like Kubernetes as a service. It's called AKS, yeah, Elastic Kubernetes Service. So they are now evaluating this, and from what I've heard, they have some difficulties with the networking model because Amazon, in this way of installation, they want you to use their ingress or their load balancers, which we don't want to use. So they are having some struggles with that. But we are definitely in the process of evaluation Kubernetes. And I think if I would go today again, and I was in the way of choosing Kubernetes or Mesos, I think I would go for Kubernetes. But I have never worked with that. I've just read some basic tutorials, haven't worked with it. Maybe there would be another. Well, right now we have perfectly working Mesos. Don't get me wrong. Like, I really like the piece of code. I attended MESOSCon like a year and a half ago, pretty big event, and I found out that what others have as problems, we have solved pretty well. So I think we are using it pretty well, and it serves us really great. I'm happy we have this piece of code, but biggest disadvantage is actual the splitness of those components. You've got Marathon, Singularity, Mesos. So when you want to upgrade it, you need to go through different components. They've got different release cycles and different terminology. It's a little bit difficult. So that's what I think Kubernetes might have been solved better. Change constraints. Well, every change of the application definition leads to a restart of the service. So, well, I can imagine, like, if you change the constraints and the application already like solves or fulfills the constraints. So in this case, I guess the app wouldn't get restarted, but that's not the typical case. So every change of the app definition leads to a restart, and all the restarts are done in a graceful way. So first you spawn new versions of the new application with the right constraints or with the right definition if you change the memory requirements or whatever. And then the old ones gets killed. And they are killed gracefully. So first you send sick term to them, wait some predefined time, and then they get sick killed if you don't respond.
So thank you, Martin, for the presentation, and thank you all for coming. all the speakers will be staying here for at least some time. I hope so. So you can use this opportunity. So you can use the opportunity and speak with them and have a beer.